So first, I will give you an overview of the load operations that are supported in Scylla. So the first one, when you have a dead node, you want to replace it, you use this operation. The token ring does not change because the replacing node will use the same tokens and the host ID of the replaced node. But it suffers from the Resumable issue. For example, you do a replace operation and it failed. 99% of the data is transferred. You do it again. You need to string all the data. This is a total waste. It also suffers from the not streaming latest copy issue. This is because it streams from only one of the replicas, but this replica might not have the latest copy. So we can solve this problem if we stream from all the replicas, but this is too heavy and wasteful to stream the same data more than once, right? So here is an example. We have 3 nodes, and we do a column write. Unfortunately, the second node missed the write. After that, if we do a column read, it's no problem. We will still have the correct answer because the strong consistency is guaranteed if we have a write consistent interval plus the read consistent is larger than the replication factor. So what happens? The third node dies, and we use another node to replace it. What do we expect from the column read in this case? This is what you would expect. So we stream the latest copy to the replacing node, but this is what might happen. So instead of streaming the latest copy, we stream the old copy. As a result, we do a column read, we will get the wrong answer. What if I'm very unlucky and we have to do another replace operation before the repair is run? In this case, the node 1 dies. We use the node 5 to replace it. So in this case, we will have to string the old copy because latest copy is lost already. In this case, the new data was lost. The second one, the rebuild operation, it used to get all the data this node owns from the other nodes. For instance, you can use rebuild operations to build a new DC because there is no node join or leaving this cluster, so the token ring does not change. However, it suffers from both the Resumable and the not streaming latest copy issue because it strings only from one of the replica. The third one, remove node operation. So when you have a node that is dead, you want to remove it. You use the remove node operation. It suffers from both problems. That is because the remaining nodes will pull data from the other nodes that owns the new ranges. And it streams only from one of the replica. Decommission is similar, but when you have a nav node, you want to remove it, you use decommission instead of remove node. It suffers from the Resumable issue, but it does not suffer from the latest copy issue. That is because the leaving nodes will push the data to the existing nodes. Here's the diagram shows this. Node 3 is the leaving nodes. It pushes the data to node 1 and 2, which is the new owner of this range. The last one is the Bootstrap operation. When you want to add a new node to the cluster, you use a Bootstrap operation. Again, it suffers from the Resumable issue, but not suffering from the latest copy issue. That is because the new node pulls data from existing nodes that losing their ranges. Here's an example. Node 3 is join, and the node 1 and 2 will send in the data because node 3 is the new owner of these token ranges. So all right, here's a summary of the operations. So basically, all the load operations suffer from the Resumable issue, but only replace, rebuild, remove node suffers from the latest copy issue. Now I would like to show you the solutions to this problem. Actually, the idea is quite simple. So why not use repair instead of streaming to sync the data? We have all the infrastructures in repair to sync the data. Last year I talked about how we improved the repair with the row level repair. So this is the foundation we can utilize. So some of the benefits. The first one is latest copy is guaranteed. Thanks to the repair, the operating node will always have the latest copy, and it's also resumable in nature. That is because repair can skip the data already synced very efficiently. For example, if you restart the failed replace operation, it can start from where it failed. Another thing is there is no extra data is streamed. For instance, you do a rebuild operation twice, it will not restream the data twice. Another good thing is that we can get a free repair during the operations. So there's no need to repair before or after the node operations. And it also simplifies the procedures, and it reduces the chances that we make mistakes when we're adding or removing nodes. It also unifies the code bases for the regular node operations and the repair operations. So we can even retire the old regular streaming code and use the same code to do both. Last is the way you operate your cluster stays the same. You can still use your favorite node to rebuild decommission commands to operate your cluster. But wait, isn't repair a very heavy operation and it's slow? So currently, the node operations assumes that the data is already synced, and the job is not the node operation itself. The job is repair to guarantee the data is consistent. So we recommend people to run repair before the operations, but the repair and the streaming operation will not faster than only doing repair alone, right? Yes, the old repair is not fast enough. That is a partition level repair, which has a so-called overstreaming problem. So the granularity is around 100 partitions. That means if a single row in that 100 partitions is different, you will have to stream the whole 100 partitions, and a single partition can be very large. So this will stream a lot of unnecessary data. However, with the new repair, which is introduced in Scylla 3.1, it has no overstreaming problems. It will only change the mismatched rows. So this builds the foundation of the repair-based load operations. So we also have optimized the repair for the node operations. For instance, we have increase the internal row buffer. So this is good for the cross-DC cluster with high latencies. We can get a higher throughput with larger buffers in this case. We also have improved the data transfer efficiency between nodes. In 3.1, we still use a old RPC verb-based repair to transfer the repair data. In 3.2, we use a new RPC stream interface, which is more efficient to transfer a large amount of data. It is as efficient as a regular stream-based operations. So now I would like to show you some of the results. So the first test is to rebuild from a single DC. And here we have 3 nodes in this cluster and 1 node per DC, and we have 3 DCs. There are 1 replica in each DC. The latency between the DC is around 80 milliseconds. So we run rebuild on 1 of the DCs. As we can see, the repair-based operation is actually faster than the stream-based one. This is mainly because internally, repair works on more ranges in parallel. And in streaming, we only stream 10% of the ranges at a time, but there is only 1 pending stream prime in parallel. However, even if repair based operation is slower than the stream-based one, for instance, not considering the parallel contribution, it is still acceptable because repair has more work to do. It has to checksum, compare. But the point is that it's much, much safer, right? The second test is to rebuild from 2 DCs. For the stream-based operation, we have to run 2 separate rebuilds. And due to this, it will stream 2 times more data, as we can see here. For the repair-based operation, we only need to perform 1 rebuild operation to sync from both DCs. And there is no extra data transferred. And the time is around 2.5 times.